For those of you who haven't spent much time with Flutter, we're an open source, portable UI toolkit designed to enable beautiful, fast experiences on any platform. Too often today, designers and developers' creativity is constrained by technology limitations. But with Flutter, we want to unleash you to build, test, and deploy beautiful mobile, web, desktop, and embedded applications from a single code base. So since our first release, we've emphasized a few different key characteristics of Flutter that we think are core needs for any developer. Beautiful, having complete control over every pixel on the screen. Fast, compiling your app to machine code rather than running code through an interpreted environment. Productive, with technologies like stateful hot reload that let you see your changes as you're working. Portable, running the same on every one of the 6 platforms, so you can develop with flexibility. And of course, open. Flutter's free, it's open source. You don't have to pay for the tools, you don't have to guess what the code is doing, you can simply go and look at it. So, just over 4 years ago at Flutter Live, we introduced our vision to bring Flutter beyond mobile to desktop, web, and embedded. And last year, we completed that journey with desktop. So we now have production support for 6 platforms, Android and iOS on mobile, and then the web, Windows, macOS, Linux. And then on top of that, we support others building embedders. And lots of others have done so, including Samsung for Tizen, and Sony and Toyota for different kinds of embedded Linux. And of course, Flutter has grown tremendously over those years. Right now, over 5 million Flutter developers have experienced Flutter since Flutter 1.0. And over 700,000 apps have been launched to date using Flutter, from small apps from entrepreneurs to those with over 1 billion downloads. And as GitHub noted in their recent Octaverse, Flutter is one of the top 3 open source projects by contributors. So, thank you.
I'm going to talk about a few things that examples of what's new in Flutter. So we've enhanced Material 3 support, as you've heard already. And this includes migration of widgets such as radio buttons, sliders, and badges to Material 3. We have adaptive layouts, which enables your app's UI to automatically scale to look great on various screen sizes. We've got menu bars and cascading context menus, which are fully customizable to your app's needs. We've made Impeller, which is the graphics rendering engine that we've been building, available now as a preview for you to use in iOS versions of your app. And to help you with the iOS app release process, the tool now validates some of the settings that you need to be configured before you actually submit to the App Store. We've also made several updates to DevTools, the suite of performance and debugging tools for both Flutter and Dart. And this includes a complete redesign of the memory debugging tool, and we've added new features to analyze the memory usage of your app. So as a designer, you're probably using tools like Figma to build detailed mock-ups of your app and its UI functionality. But sometimes translating that vision to code takes multiple iterations and back and forth with your development team, which is really tedious to tweak things and get it just right. Widgetbook. So let's open up Widgetbook, and we'll take a look in this clip here. On the left-hand side, we can see all the different components of the app. Clicking on one of them, you can adjust what it looks like and see what it looks like in the middle view here. And on the right, you have all these settings that you can see how it looks. In this case, you can play with the theme right now. You can go on and change your locale and so many other things. And this is great to test things out and make sure everything is working as planned. But with Widgetbook Cloud, we can go a step further. So by integrating with CI/CD tools and giving designers a complete platform to review changes. Now, as a developer, I'll create a commit to update the app. And with a GitHub action, Widgetbook will automatically create an updated hosted library. As a developer, you can then send that link over to the designer for review. All right, now I've got the link as a designer. And I'm going to click on it, as you can see here. And in this next view of Widgetbook, you can open up the link, and you can see even better, we've now got, with Widgetbook's new Figma integration, you have the design on the left, and you have the new implementation on the right. And as before, you can use the same set of knobs and features to look at the app. And comment, or in this case, we accept it.
PUBG Mobile 目前全球有10亿玩家，日活跃5000万，由光子工作室及 Craftdown 联合研发。
I am happy to announce Dart 3 Alpha. This is the first release, the first preview of our next major release, and I have 3 things I would like to show you today. We have new language features. We have the completion of our multi-year journey towards sound null safety. Oh, and we've expanded on our already comprehensive platform support. Would you like to hear all the details? Yes. All right. I will start with records and patterns. These are large new language features focused on making the Dart language more expressive and better suited for working with structured data. But in ftalk, let's look at some code. Here is a Dart2 function that takes a place and returns a location. Currently, to return both latitude and longitude, we put both values into a list. That means over here on the caller side, we need to read out the latitude and longitude manually using positional access. Let's hope we don't get those pesky indexes wrong. To work around that, we could also define a new location class. This makes it a lot easier to get latitude and longitude out in a type-safe way. But it's really verbose to have to name and define some class just to bundle up 2 integers. To solve this, Dart3 adds a new type of built-in collection called records. As you can see, a record looks sort of like a list row, but you can use it in code with parentheses instead of the square brackets. And notice, here we're using it to return a pair of 2 integers, giving you multiple return types, which I know many of you have asked for a really long time. All right, over on the caller side, we now get back the pair of integers. And to read out both the latitude and longitude, we now again use positional access. I personally really like the syntax for defining the record up here on our getLocation function. But let's see if we can get away from the positional access when we read out the elements. And to do that, we're adding patterns and pattern matching. This can be used to destructure existing structural data back into the individual elements. As you can see, the highlighted code is matching against the pair coming back from getLocation. And very easily, we can read out latitude and longitude, and then just go ahead and use them. If you want to, you can also discard one of the fields using the underscore pattern. Sometimes you might want to just update existing variables instead of binding new ones, and in that case, you can of course do that too. Let's talk about null safety. Sometimes, to make progress in a product, it is insufficient to simply add features. Sometimes you have to be willing and go back and revisit your earlier assumptions about existing features. The Dart team has been on such a journey for the past 7 years to rework the Dart type system. I personally joined the Dart team nearly 7 years ago, which was around the time of Dart version 1.11. And back then, Dart had a novel, but honestly put, also quite confusing type system. Types were merely annotations, and if you ignored the optional warnings from the analyzer, you could entirely bypass the type system. Here we are assigning a string to something declared to be an integer. What would happen? You would get catastrophic exceptions when your app ran in production. In 2018, we launched Dart2, featuring a new strong type system. This turned Dart1's exceptions after deployment into development time errors. In Dart 2.12, we took another big step. We added sound null safety, which allowed you to catch null errors during development. This avoided a whole class of issues often seen in production apps. In Dart 3, the major version increment signals the completion of this multi-year journey. Your Dart code now always runs with the sound null safety, and you will no longer be able to run without it. This makes Dart easier to understand. All Dart code now runs in a single mode. And thanks to the great work by the Dart community, that's all of you, we think we're ready for this change. For packages on pub.dev, 98% of the top 1,000 packages have already migrated. Thank you. We expect Dart 3 Stable to launch later this year, but today we're making Dart 3 Alpha available to enable you to test for compatibility. But notice, we expect the vast majority of code already migrated to null safety will simply work. Check out the website and today's blog post for details. But, sound null safety is not just about catching null errors. There is more. Do you care about performance? All right, I thought so. I'll hope for it. Sound null safety allows our compilers to trust the types and produce smaller and faster code. Here's an example. This is a small function that takes an argument and returns a result. When this code compiled to machine code with Dart 1, our compiler produced 26 machine code instructions to have all the needed runtime checking in place. With sound null safety in Dart 2, we could reduce this down to 10 instructions. And in Dart 3, with sound null safety everywhere, we're now down to 3 instructions. And this was just a simple function call. Imagine a large real-world program with thousands of lines of Dart code. It adds up to a huge change. All right, let's get to my third and last theme, portability. And again, this is all about enabling you to deliver apps to all the platforms your customers care about. Dart's high portability has already enabled Flutter apps to target the 5 major operating systems and the web. And on these platforms, our native compilers support a wide range of processor architectures, including ARM and Intel, in 32-bit and 64-bit architecture. On the web, we currently compile to JavaScript, where we use our enterprise-class compiler that powers some of the largest web apps at Google. New in Dart 3,
Rive. Rive is rapidly becoming one of the most popular ways to build interactive graphics, whether you're targeting Flutter or another platform. And for Rive, the editor itself is written in Flutter on the web. And in fact, it was one of the first things to be built with the web on Flutter. And apps like this, with their complex visual needs and their complex UI needs, are really hard to do without a framework like Flutter. So Flutter's web support is still pretty new, but this version of the Flutter web app is not using JavaScript. In fact, if I go into the dev tools and I make that a little bit bigger, you can see that what we've got here is, instead of the usual sort of main.dart.js, which is normally the big thing that contains everything, we've got main.dart.wasm. And this is the compiled version of this code to WebAssembly. Adding to the complexity of this, WebAssembly has been around for a little while, but the bit that is new is WebAssembly GC, which is a new in-development standard for garbage-collected languages. And Flutter is one of the very first garbage-collected languages to support this extension to the WebAssembly standard when it comes out. So now we get all the benefits of WebAssembly from a loading perspective in terms of performance, and we also get the ability to go and interoperate with other languages that are compiled to WebAssembly. So that's coming soon, support for compiling to WebAssembly from Flutter in the web. Element embedding. And this is another shift of work that we're doing, another piece that we're doing to improve the quality of the web experience with Flutter. So again, if we go back to the demo machine here, In the past, when you have built Flutter web applications, typically you've taken over the entire screen. Occasionally you might choose to put it in an iframe and integrate it within the rest of the web app. But the problem with that is you're in a sandbox. It's tough to get out of that and communicate backwards and forwards with different parts of the application. Something that we've been working on here enables you to take Dart and Flutter and compile it and put it in a div as a web component, so it can integrate deeply with the rest of the platform. So I'm going to show you this as well. I'm just going to show you in DevTools. You can see here what we've got. This is just regular HTML page that we've got here. You can see all these buttons here. They're all actually just HTML buttons on the left-hand side here. And what I've got here is this single div here, which is the div target for the Flutter. And that's where the Flutter component is going to be loaded. So I'm going to get rid of the DevTools for a moment. And this is the div here. And you can see that through a bit of JavaScript code, we've filled that with the Flutter counter application. So now you can see that I can do the usual things. This is the traditional Flutter counter app. But look, on the left-hand side, what you're seeing here, this is JavaScript. This is a JavaScript text box. And you see that as I continue to increment the button on the Flutter side, that state can be pushed across to the JavaScript side. Better still, I can go the other way as well. So I can hit the increment button on the JavaScript side and affect the state in Flutter. And because what you're looking at here is just a regular HTML div, you can do other things with it. You can, for example, apply CSS. So I could add a shadow effect. That's kind of nice. Or I could resize it in real time. Or I could even switch it into a device mode and skew it. But it doesn't just go there, because I can also flip it across. I can go into something like a text field. And these are the things that are often quite difficult to implement. But even in this text field mode, if I switch again back into that device mode, you can see that the text field still works. I can do selection with skews. That's all pretty good. Let's switch it up again a little bit more. Let's make it back into landscape mode. And let's add a spin. Oh, check that out. OK, but this is live, right? So I can still go backwards and forwards here. And I can select text, and I can it gets quite challenging when I'm doing it in reverse. I can type into it, and it's still working. This is just like a text field in CSS with CSS effects. How about... How about for a bit more fun, I'll just add a CSS mirror effect. So now what you're seeing here is the CSS reflecting of the Dart code here. So again, I can continue to make these changes, and you can see it reflected at the bottom. What do you think? Pixel shaders are a low-level function that you can run locally on the GPU that give you a lot of power for doing hardware-accelerated graphic effects. You can do things like blurs and glows. You can invert pixels. And a pixel shader runs on every pixel that's about to be rendered on the screen and lets you make changes to it. We've had this for a little while on Flutter for mobile, but now, with the work that we're doing here, again, very experimental, very unstable, we're bringing it to the web. So if I can go back to my demo machine, this is a pixel shader demo that Eric Gomez wrote. And what you see here is just a very simple example of pixel shaders at work. There's our famous Dash. And with this slider, I can change how pixelated she is. And this is exactly the same code that Eric wrote and demonstrated for mobile, but we've just taken it and transformed it, or just taken it and compiled it for the web. And now I can do all these kind of really crazy cool effects, like adding this kind of pointillism sort of view. And you can see that this is just what goes on as it's loading different images and applying these pixel shaders. So again, the power available with Flutter to do these high-end graphics effects is now available on the web.
Over the past year, we've continued to add lots of exciting new features. We've been improving text input, we've been adding support for foldable devices and variable refresh rate. We've been simplifying release processes, enhancing our developer tooling, and improving performance, just to name a few. All right, let's consider a news app. I think we can all agree that more and more people are reading news on their phone. But for developers, that means building navigation and search, authentication, ad integrations, profiles and subscriptions, notifications. It's a lot of work. So to help with this, we're excited to announce that the first version of Flutter's News Toolkit is now available for everyone. First up, I have my Samsung Tab 8, which is a pretty big tablet. And I can swipe through the app and see these beautiful graphics, all this great imagery. And it looks really nice on this larger screen, right? But now with these tablets, we have lots of different multi-display modes. So I can drop a new app into view and see it resize. And it still looks really natural on this new format. Now let me add another one, and we'll see it resize again, looking great. So let me get rid of this one down here and make it even narrower. And still, we see that it looks beautiful, even on this really narrow screen that it's left with. Okay, so like I said, this looks great, but let's head over to a different screen. I'm going to go over to this view where I can see a timeline of different events for that wonder. Here they're vertically stacked, and I can scroll through. But now when I open it, I'll scroll down to that same page, and we can see that we have a whole new format. Right, so this is really just two screens side by side, and we're taking advantage of that by having the imagery on the left-hand side and the scrollable events on the right-hand side. So, looks great. Okay, so switching gears a little, let's move on from developer experience and focus on interoperability. So when I think of what makes a mobile app different from something on the web, I think of things like notifications, payments, accessing a user's location, or looking at their photos. There are literally thousands of APIs, but the tricky part is you have to worry about two different platforms, and each is written in a different language. So say I want to start tracking my daily steps in a new pedometer app. On Android, I might use the new Health Connect client, and on iOS, maybe I want to use the CM pedometer class that's part of the Core Motion framework. So in the past, we'd probably use method channels to call these APIs, but that can sometimes require a lot of code. So now looking forward, our vision is that you can call all these APIs directly from Dart, access platform APIs. Now let's move on to our last theme for mobile, which is graphics performance. So like Tim mentioned before, we recently started supporting custom fragment shaders with Flutter. And it's been really fun scrolling through Twitter and seeing all the funny things that people are creating. We have glowy text, we're making it snow, we have some waves going on, really cool stuff. So one feature that we're super proud of is Impeller, which like we mentioned before, is a major rewrite of our graphics engine. For now, you can turn it on for iOS with this flag, but we're planning to turn it on by default in the next stable release, so long as we get good feedback. So please give it a try and let us know what you think. Impeller is a multi-year investment, and our primary goal is to eliminate shader compilation jank and also to match or hopefully beat our current per frame metrics. And you can see for yourself just how smooth Impeller is by installing Wondrous for iOS. But in some edge cases, like complex SVG clipping, we can see Impeller making a really huge performance difference. So let's see an example. Cool. So I have this fun little kaleidoscope app, and it has some animations that were created by clipping a whole bunch of different SVGs. So on the left-hand side, I have my build that's using Skia, which is our current default renderer. And as we're scrolling down the page, we can see that it struggles a little bit. It's only rendering at about 7 to 10 frames per second. But on the right-hand side is our build using Impeller, which looks really smooth. It's rendering at like 60 frames per second. 3D logo, there we go. All right, so who wants to see me make a 3D dash painted entirely in Flutter? All right, let's give it a try. So right now I have a pretty simple widget, or a pretty simple app rather. It just has an image widget to display a 2D version of Dash that's created from this PNG file. So nothing fancy. She's looking cute, but I really want to make her 3D. So let me go ahead and switch out this widget over here, and instead we're going to use a scene. And scene accepts a node, which can take an asset. And in this case, my asset is going to be a model file. It's actually something called a GLB file. So I'll save that, oops, and reload. And she's 3D. So she's just in this cool little light box, and we can turn her around and see how she's looking. So that looks great, but if you're new to 3D, you're probably wondering, what is this GLB file? So this GLB file is just a pretty common way to express 3D data. And you can actually create them or edit them in different tools. This one that I'm using here is called Blender. All right, let's give it a try. Ta-da! She's hot pink. She looks a little sunburned, I think. I think Dash looks pretty nice, but 3D gets really cool when we can add in animations. So I'm going to go ahead and add in an animation. These are just saved in my file already, so I just call them by their name, which in this case is walk. I'll save, and again, hot reload, and we can see her walking around. But the thing is that we were just talking about performance, so I think we need to turn it up a notch, right? Instead of just showing a single dash, I think we want to show a whole bunch of dashes. So I have my helper function called many nodes, and I'm going to wrap it around my node object. Press save. Again, we'll hot reload. And now we have a whole bunch of dashes.